Hello, my dear puzzle enthusiasts. Welcome to our channel. We teach children how to solve the Rubik's Cube and other puzzles. And today in our lesson, we're going to solve the square 1. What makes our lessons unique is that we post all the diagrams and algorithms on our website at Cubearea.fun. That means you don't have to rewatch our video lesson every time. You only need to watch the video lesson once or twice, and after that, you can just go to our website, look at the diagrams and algorithms, which makes solving any puzzle easier and faster. And you can also download these instructions in PDF format to print them and use them for assembling your puzzle. Well, let's get started.
Cubearea is where we start, solving puzzles with a master's art. From the first twist to the final move, watch as colors groove. Lessons clear, easy, no need to stress. We'll go step by step, no second guess.
When scrambled, this puzzle takes on all sorts of shapes, but in just 5 steps, we'll solve this beautiful cube, and it will look like this. The puzzle consists of 3 horizontal layers: the top, middle, and bottom, and 2 vertical layers, the right layer and the left layer. This puzzle has 2 main types of pieces. The first type is the edge piece, and the second type is the corner piece. A corner, just like in a regular Rubik's Cube, has 3 sides and 3 colors. We will solve the puzzle starting from the position where the short part of the orange middle layer is on the left. When scrambled, it will look like this. All algorithms will be performed from this position. We'll solve the yellow side on the top layer and the white side on the bottom layer. Let's talk about turning layers. In our diagrams, you'll see a move called a slice. Turning the top layer clockwise is denoted as U and counterclockwise as U prime. Turning the bottom layer clockwise is denoted as D and counterclockwise as D prime. What do we mean when we say clockwise and counterclockwise rotation? If you imagine turning a layer like opening a jar lid, opening the jar is counterclockwise and closing it is clockwise. It's the same if the layer is on the bottom. Opening is counterclockwise, closing is clockwise. The diagrams also include numbers. Let's figure out how to perform rotations with numbers. For example, U3. If you look at the elements of the top layer, you'll notice that a corner consists of 2 faces, while an edge has 1 face. All rotations are counted relative to this slice line. So, a U3 rotation means that, relative to this line, we need to turn 3 faces. 1, 2, 3. Let's do this rotation. 1, 2, 3. Now let's reverse it. Let's do a U3 prime move. 1, 2, 3. That was a U3 prime move, which means turning the top layer counterclockwise. Our goal in the first stage is to turn this shapeless puzzle into a perfect cube shape. Assembling the cubic shape in the first stage consists of several sub-steps. To start, on the top layer, we need to gather all 8 edges together and 2 corners, while on the bottom layer, we'll only have corners. Next, we do a slice move, and we get a shape on the top and bottom layers that looks like a jellyfish. We do another slice, and now on the top and bottom layers, we get a turtle shape. We position the top layer like this and the bottom layer like this. We do another slice and we get a shape that looks like a kite. We do another slice and now we have a cubic shape. Sometimes at the first stage, it's not possible to gather all 8 edges together on the top layer. But you'll notice that you can gather 7 edges together, with one edge separate between 2 corners. If you manage to assemble this combination on the top layer, then we'll use this algorithm. Next, we'll get the 8-0 combination we need and go through all these sub-steps to achieve the cubic shape. First, let's hold the puzzle correctly. The orange color should be right here in front of us. Here it is. Also, this short side should be on the left. Maybe your puzzle looks like this, and that's perfectly fine too. Don't pay attention to this middle layer here because we're going to rotate it many, many times in the first step. Here, your middle layer will keep changing, and we'll fix it later. Our goal is to try to gather all 8 edges together on the top layer. But if that doesn't work out, we can assemble a combination of 7 edges together here and 1 edge between 2 corners. So, we make slices from the correct position, and to combine as many edges as possible, we need to align the cut line of the edge on the top layer with the edges of the bottom layer. Here, for example, is the cut line. On the left of the cut, I have 2 edges, and on the right of the cut, I have 3 edges. And when I make a slice, I get 5 edges together. Now, let's see where else we have edges on the bottom layer. Right here. I can turn them over here to the cut line. I realize that if I rotate like this, my combination on top will break apart. So I move this completed combination into the safe zone. The safe zone is on the left because the right side is the rotation zone. Well, let's try to do it. So now we have 6 edges together, and at the bottom we have 2 separate edges. In this situation, I can turn the top layer like this. This is the safe zone, and it's on the left side of the rotation. And now I'll move this part to the top layer. That way, I'll get a 7-1 situation. We're just following logic here, and if you're lucky enough to get all 8 edges together, that's great. But if you're not that lucky, the second situation you'll encounter is the 7-1. When you have a 7-1 situation, you need to perform a special algorithm. To execute the algorithm, the setup is, on the bottom, there's just a star, don't pay attention to the colors, and on top, the 7-1 situation should be positioned so that to the left of the cut line is a corner and to the right is an edge. Apply the algorithm. Slice, U twice. 1, 2. Slice, U counterclockwise 5 times. 1, 2, 3, 4, 5. D clockwise 4 times. 1, 2, 3, 4. Slice, U twice. 1, 2, slice. After performing the algorithm, we get the 8-0 combination. 0, because there are no edges between the corners. All 8 edges are right here. Now we need to hold the puzzle like this, with the star on the bottom and the top layer in this position. Do a slice. We get a jellyfish on top and a jellyfish on the bottom, mirrored. There's a jellyfish here and a jellyfish here. Do a slice. We get a turtle here and here. On top, the turtle is in this position, and on the bottom, the turtle is in this position. Do another slice. On top, we get a kite. Position it like this. And on the bottom, we also have a kite. Place it as a mirror image relative to the top layer. Do another slice. And we get a solid square on the top layer and a solid square on the bottom layer. If your middle layer, just like mine, looks unsolved, you can use the following algorithm.
You slice U 6 times 1, 2, 3, 4, 5, 6. Slice U 6 times 1, 2, 3, 4, 5, 6. Slice.
And the centerpiece moves into its correct position. In your case, the centerpiece might already look nice and even, so you might not need to fix it. In the second step, we need to place all the yellow corners on the top layer and all the white corners on the bottom layer. We assemble the corners in the second step intuitively. First, hold the puzzle correctly. The orange middle layer should be facing you, and the small side should be on the left. My goal is to move these two white corners to the bottom layer and get these two yellow corners onto the top layer. As always, we use a slice, but before making the slice and sending the white corner to the white side, we need to do a U rotation, like this. Because if we do the rotation from this position, we break the cubic shape. So before the slice, we do a U rotation, and now I send this corner to the white side. This corner is on the white side. Here we got yellow. Now I want to move these two yellow corners into the safe zone. It's on the left side of the cut line. And here I want to get, on the right side of the cut line, the opposite, two yellow corners, because I want to move them to the top layer by rotating. Both of these corners are in the rotation zone on the right. And these two yellow corners are in the safe zone on the left. And when we do the slice, these two corners move into their correct positions, and all four yellow corners are on the top layer. Turn the top layer to restore the shape. The white corners are on the bottom layer, and the yellow corners are on the top layer. The step is complete. In the third step, our goal is to place all the yellow edges on the yellow side and all the white edges on the white side. Don't pay attention to the side colors. Please open the diagrams on our website. In the third step, we have two main algorithms that will help us assemble the edges on the top and bottom layers. Next, we'll just look at a few cases that are based on these two algorithms. Algorithm number 1 allows you to move an edge from the top layer down to the bottom layer here, and an edge from the bottom layer here up to the top layer here. This is algorithm number 1. we'll use the second algorithm when we need to swap two edges from the top layer that are opposite each other with two edges from the bottom layer that are also opposite each other. Next, let's look at some situations. Here's a situation where you have three edges on the top and three edges on the bottom. For this, we'll use algorithm number 2, which will let us move these two opposite edges down and these two opposite edges up. Then, using algorithm number 1, we'll swap the remaining two edges. In this situation, we just use algorithm number 2 twice. All right, let's move on to practice. Situation, we need to move three white edges down to the white side. First, we'll use algorithm number 2, which will send these two white edges down. And these two yellow edges will go up. We apply the algorithm from this position, two white edges here and two yellow edges over here. I'm applying the algorithm U slice, U prime, D prime, slice. Now we have one edge left on top and one edge on the bottom. We're going to use the first algorithm. The edge on top should be on the right. And this edge should be right here. Now we apply the long algorithm.
U slice, U3, 1, 2, 3, slice, U3, 1, 2, 3, slice, U prime, D prime, slice, U3 prime, 1, 2, 3, slice, U prime twice, 1, 2, D, slice.
All the edges on the top layer are assembled, and the bottom layer is also complete. The situation is 4 white edges on the top layer and 4 yellow edges on the bottom layer. In this case, we just need to apply algorithm number 2 twice. Algorithm number 2, send these two white edges to the white side and these two yellow edges to the yellow side on top. We apply the algorithm
U slice, U prime, D prime, slice.
Now we have two edges left on the top layer and two edges on the bottom layer. We apply the algorithm from this position.
U slice, U prime, D prime, slice.
Align the layers. This step is complete. In the fourth step, we assemble the corners of the top yellow layer and the corners of the bottom white layer. At the fourth step, you might encounter completely different situations, but we only need two algorithms to solve any of them. We use algorithm number 1 when all the corners on the bottom layer are already assembled. In other words, algorithm number 1 only moves the corners of the top layer. And the second algorithm affects both the top and bottom layers, specifically by swapping them. These two corners on the top layer and these two corners on the bottom layer. These two algorithms are enough to solve any situation that you might encounter in your puzzle. The assembled corners look like this. They are on the same side and have the same color. For example, here are two red ones together, two green ones, two orange ones, and two blue ones. Situation. I have only two solved corners on the top layer, right here. These two corners are not solved, and on the bottom layer these two corners are not solved, and these two corners are not solved either. So there are only these two solved corners. Algorithm number 2 will help me here because it swaps these two corners and also swaps these two corners. Let's apply this algorithm and see what happens.
Slice U3, 1, 2, 3. Slice U3 prime, 1, 2, 3. D3 prime. Slice D3 and slice.
So these two corners stayed the same. These two corners are solved and on the bottom layer. We also have two solved corners. So what do we have here? At the top, all the corners are collected, and at the bottom, only these two corners are collected. So we need to solve these two corners. We have formula 1, which doesn't change the corners on the bottom layer, but does change the corners on the top layer. In a situation where the top corners are solved, but there are still two left to solve on the bottom, you need to move all four white corners to the top layer. Apply the first algorithm. How do you move all four white corners to the top layer? First, we do Yule, sending these two corners to the top. Then move them to a safe zone. Now, we move these two white corners into the action zone and do a slice. Now we have all four corners on the top layer. Let's analyze what happens when we perform algorithm number 1. Execute the algorithm. We will start from a position where these two solved corners are right here on the back side. What will happen? After performing the algorithm, these two corners will simply move. They'll move here, so they'll stay together as a pair, red and red. This corner will move over here and take this position, meaning its orange side will be here. And if we look, this corner here is also positioned with the orange side, right here. So, performing algorithm number 1 from the position where these two corners are solved and these two are not will allow us to solve all four corners. Let's apply the algorithm.
Slice U3, 1, 2, 3. D3 prime, 1, 2, 3. Slice U3 prime, 1, 2, 3. Slice D3, 1, 2, 3. Slice D3 prime, 1, 2, 3. Slice D3, 1, 2, 3. Slice.
Let's take a look. These two corners are solved. These two corners are solved. And these two corners are also solved. All our white corners are collected in yellow. They're also solved. Now we need to swap them. Send the white side down and send the yellow side up. Let's do the following move. U. Move this part down. Now move this yellow half into the safe zone. And move this white half into the safe zone on the left as well. And when we make this kind of turn, all the corners here. We have yellow here, all the corners, and we have white here and all the corners. Matching color. With the centerpieces, in the fifth step, we solve the edges of the top and bottom layers. For the fifth step, we'll need 4 different algorithms. The first algorithm lets us swap these two edges on the top layer and these two edges on the bottom layer. The second algorithm lets us swap these two edges on the top layer and these two edges on the bottom layer. The third algorithm moves only the edges of the top layer counterclockwise. And the fourth algorithm swaps two edges only on the top layer. We'll also look at situations you might encounter, but whose solutions are based on these four algorithms. But now, let's move on to practice. Here's the situation. There are two edges left on the top layer that need to be swapped, and on the bottom layer as well. There are also two edges left that need to be swapped. Executing algorithm number 5.1, which will allow you to solve this situation, is done from the position where the two edges on the top layer are here and the two edges on the bottom layer are here, on the right and at the back. Let's apply the algorithm.
U slice U3 1 2 3 slice U prime D prime slice U prime twice 1 2 D slice.
That's it. All the edges are in their correct places. Here's the situation. On the top layer, there are two edges left that need to be swapped, and they are directly opposite each other. And on the bottom layer, these two edges are already solved, but these other two edges need to be swapped. In this situation, algorithm 5.2 will help us. You apply the algorithm from the position where the two edges that need to be swapped are here, and the two edges on the bottom layer that need to be swapped are here. I apply the algorithm.
U slice U prime D prime slice U 6 times 1 2 3 4 5 6 slice U D slice.
Restore the puzzle, and now all the edges are in their correct places. Here's the situation. All the edges on the bottom are solved, but there isn't a single solved edge on the top. But if you rotate the top layer and match an edge with its corresponding centerpiece in C, for example, orange-orange, blue-blue, green-green, and red-red, that means we just need to perform the 5-3 algorithm, rotating the edges counterclockwise. And in my case, like here, I only need to apply the algorithm once, and this orange edge will move to this spot on the orange side. The blue edge will end up on the blue side, the red one on the red side, and the green one on the green side. Well, in your case, it might take 2 repetitions, but 3 at most. Let's apply the 5.3 algorithm. I apply the algorithm slice U3. 1 2 3 D3 1 2 3 slice U a slice U prime 2 1 2 D prime 2 1 2 slice U2 1 2 slice U2 1 2 D2 1 2 slice U prime slice U prime 3 1 2 3 D prime 3 1 2 3 slice U prime 2 1 2 slice U2 1 2 D2 1 2 slice. That's it. All the edges have made one move counterclockwise and are now in their correct positions. In your case, this might require running the algorithm twice, but 3 times at most. Here's the situation. All the edges on the bottom layer are solved, and on the top layer, there are only 2 edges left that need to be swapped. To solve this, we'll use algorithm 5.4, which allows us to swap 2 edges on the top layer. Let's apply the algorithm slice. U prime 3. 1, 2, 3. Slice. D3. 1, 2, 3. Slice. D prime 3. 1, 2, 3. Slice. D3. 1, 2, 3. Slice. U2. 1, 2. Slice. D2. 1, 2. Slice. U prime 2. 1, 2. Slice. U4. 1, 2, 3, 4.
Slice. D prime 2. 1, 2. Slice. D2. 1, 2. Slice. U prime. D4. 1, 2, 3, 4. Slice. D prime 3. 1, 2, 3. Slice. D3. 1, 2, 3.
That's it. All the edges are now gathered on top. And as for how to fix the center layer, we already know that. You then do a slice. Now just move the white side into the safe zone. Do a slice again. Now move the yellow half into the safe zone. And do a slice again. The center layer is aligned, all the edges are assembled, and we've solved the puzzle. Here's the situation. The bottom layer is completely solved, and on the top layer, there's only one edge that's assembled. The 3 remaining edges are not assembled. Let's analyze this. We have an algorithm that moves the edges on the top layer counterclockwise. Let's try rotating the top layer and analyze what happens to the edges. For example, if I turn it once, I notice that after running the algorithm, I can get the orange edge on the orange side and the green edge on the green side. In this case, in my current position, I only need to perform the algorithm once, and these 2 edges will be in their correct places. In your case, if these 2 edges, for example, are over here, then you'll have to perform the algorithm twice. First, they'll move here, and then they'll move here. I return, restore the orange side, the corners, and the orange side, and I will apply the 5-3 algorithm from this position, and these 2 edges will shift counterclockwise like this and end up on their correct sides. I apply the algorithm. Slice U3. 1, 2, 3. D3. 1, 2, 3. Slice. U a slice. U prime 2. 1, 2. D prime 2. 1, 2. Slice. U2. 1, 2. Slice. U2. 1, 2. D2. 1, 2. Slice. U prime. Slice. U prime 3. 1, 2, 3. D prime 3. 1, 2, 3. Slice. U prime 2, 1, 2. Slice. U2, 1, 2. D2, 1, 2. Slice. Let's see what we've got. And here's what happened. These two edges are now in their correct positions, and we just need to solve these two edges. But we also have the 5-4 algorithm, which lets us swap just these two edges on the top layer. Hold the puzzle like this. The small part of the orange center layer is right here. The two edges we're working with are right here. Let's apply the 5-4 algorithm. Slice. U prime 3. 1, 2, 3. Slice. D3. 1, 2, 3. Slice. D prime 3. 1, 2, 3. Slice. D3. 1, 2, 3. Slice. U2. 1, 2. Slice. D2. 1, 2. Slice. U prime 2. 1, 2. Slice. UR4. 1, 2, 3, 4. Slice. D prime 2. 1, 2. Slice. D2. 1, 2. Slice. U prime. D4. 1, 2, 3, 4. Slice. D prime 3. 1, 2, 3. Slice. D3. 1, 2, 3. The edges on the top layer are now assembled. Now we just need to fix our centerpiece. U. Slice. Now move the white side to the safe zone. Slice again. Then move the yellow side to the safe zone and slice again. Restore the top layer. That's it, we've assembled the edges. Let's look at another possible situation. Here's the situation. The bottom layer is solved, and on the top layer there are two edges left, which are opposite each other. And we need to move this orange edge to the orange side over here, and this red edge to the red side over here. In this situation, we'll start by using the 5-3 algorithm. The 5-3 algorithm rotates the edges counterclockwise. As a result, this orange edge from here will end up here. On the green side, this green edge from here will move over here. This red edge will move over here. And this blue edge will move over here. And in this situation, we can see that here the blue edge is on the red side, and here the red edge is on the blue side. This means we need to swap these two edges. And here, the orange edge is on the green side, and the green edge is on the orange side. So, we can see that these two edges also need to be swapped. But we have an algorithm that allows us to swap two edges on the top layer and two edges on the bottom layer. So in this situation, we'll do a slice move. We'll send this pair of edges, the blue and red ones, down to the bottom layer right here. And the green and orange ones, according to the plan, will stay here. And after performing the 5-1 algorithm, these edges will be solved. Then we'll do another slice and move the entire yellow side back up to the top layer right here. That's the theory. Now let's look at how it works in practice. Here it is, this situation. The bottom layer is solved, and on top there are two edges left that need to be swapped. We perform the 5-3 algorithm. The 5-3 algorithm rotates the edges on the top layer counterclockwise. I'm applying the algorithm. Slice. U3, 1, 2, 3. D3, 1, 2, 3. Slice. U. Slice. U prime 2, 1, 2. D prime 2, 1, 2. Slice. U2, 1, 2. Slice. U2, 1, 2. D2, 1, 2. Slice. U prime. Slice. U prime 3, 1, 2, 3. D prime 3, 1, 2, 3. Slice. U prime 2, 1, 2. Slice. U2, 1, 2. D2, 1, 2. Slice. Now we see that the orange and green edge pieces need to be swapped. And here, the blue and red edge pieces need to be swapped. To do this, we need to move this pair of edge pieces to the bottom layer. We do it as follows. That's it. This pair of edge pieces is now on the bottom, and this pair of edge pieces stayed on top. Next, we will use algorithm 5.1. Algorithm 5.1 will allow us to swap these two edge pieces on the top layer, and also swap these two edge pieces on the bottom layer, the blue and red ones. They are on the right and in the back. And on top, the edge pieces are here. I apply algorithm 5.1.
U, slice, U3, 1, 2, 3, slice, U prime, D prime, slice, U prime twice, D, slice.
Let's take a look. These two edge pieces are now in their correct positions, and these two edge pieces are also in their correct positions. Now this yellow piece needs to be moved to the yellow side. We position it in the rotation zone and bring it back to the top. That's it, all the edge pieces are assembled. The 4 algorithms we've covered are more than enough to solve any situation you might encounter. You just need to think and analyze what the algorithms do and how they can help you.
Step into the zone where puzzles come alive. Cubearea.fun, teaching kids to thrive. Twist it, turn the Rubik till it's all aligned. Colors spinning fast, gotta sharpen your mind. Cubearea is where we start, solving puzzles with the master's art. From the first twist to the final move, watch those colors groove. Lessons clear, easy, no need to stress. We'll go step by step, no second guess. Free for all the kids who wanna be the best. Rubik's secrets will divest. Cubearea.